Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Kirk Gray.
Hey, Kirk, you were just mentioning something that's sparked an idea for a topic, and it's similar to a couple of questions that have come in that, you know, there's this whole philosophy that you wait till something fails and then you go fix it, right?
Right.
And then there's another realm of folks that's saying, you know, with good engineering practices and good, understanding of how things fail, is you can identify, say, the weak point and then make that more robust. And there's techniques for doing that to discover or use HALT, for example, to find the weak points are and go fix it. Right.
Right.
But what sparked it was you were talking about that you have a fence and a gate getting repaired today. But it was interesting the way you phrased it, the way the guy said, here's what we need to do.
Right. So basically this is a wooden fence, 6 foot high, post, sunk in concrete in the ground. And the part of the post holding the gate hinges and actually has to hold the weight of the gate as it swings open, had actually broken at the base where it entered the concrete reinforcement.
Did it break like a car run into it, or did it break because it got eroded, corroded away?
It was just basically fatigue damage over many, many years of that displacement of the weight of the gate swinging open. It actually, moves the weight post a little bit. The weight actually, right. So the constant opening and closing of the gate finally had enough back and forth and weight that it broke at the ground. And ways to prevent that would have been if I had a metal post,
if we're going to brainstorm, you could skip the fence altogether.
But anyway, so I got a guy that's very experienced. Looks like he says 10 years or more experience, and he's done a lot of fence repair. So basically he, today when he talked about what he needed to do, he said, we need to add another fence post in the 16-foot section so that you don't get as much weight displacement on and movement on that pole that's holding on the fence post that is actually having to bear the weight of the gate swinging open and the torque of that weight. So, this is where he foresaw, and probably from his experience of working on fences so much, that he's seen this before. And he knows that this is what happens when you don't have enough support on the fence section itself. Plus the wind blows that fence back and forth. Puts pressure on the post, and over who knows how long this was in existence. The house was built in 1983. I can't imagine that they had it. They may have had it back then, and it's quite aged. So he's out there replacing and adding another fence post.
So you get another 50 years out of it.
Or whoever lives here.
But what made me think about it is this guy's, his experience and his eye of looking at this structure going, if we do this, we'll make this, the chance of this new post failing in some way, some time in the distant future, we'll make it more robust. It'll last longer.
Exactly.
And
that's what he did.
It makes it more structurally sound. And it reminded me of looking at products. I worked on a variety of different new products being designed, electromechanical systems. And I know you did a lot of field service and failure analysis side of it. And we're constantly looking at, why it will fail or what is likely to fail. Once I'm here, what doesn't look right? What do I need to fix also? So I'm not back out here next week. I don't know. It depends on how you're paid. You might want it to be out there next week.
And he could have just wanted to sell me another post.
And says, 2x2 will work just fine here. I'll bring you a dozen of them because we'll put one in every week. Yeah. But the issue is how do you, the way you described it, this person has the experience. And I know that you and I both have experience of looking at different designs and different products and how things, but we've done lots and lots of failure analysis over the years. Right. But how do you do that when it's something new, or you're working on something that's unique, or it's still on schematics, or you're still on CAD, you haven't built one yet? How do you identify weak points? And the reason I bring it up is that with any product, anything that we design and develop, whether it's a fence or a cell phone, there's lots of ways this thing can fail, right?
Sure.
Yes. And we can't solve all of them. And some will not fail for a long, long time, even if we don't pay any attention to it at all. And others will cause half of them not to survive shipping. So how do we... is there a process that you know of that helps us identify and focus in on those points that we do actually need to solve?
Well, this is a course where experience, I think, Lynn, is terribly critical.
So you got to hire old people to come help you?
Well, you ought to listen. You ought to listen to people that have seen this kind of thing, because there are very few products that, out of the chute are just completely radically, you never know those materials have been used before, there's always something that traces back to something we've had before. We build on the knowledge, just like we build on the knowledge of our mentors and people we've known, like Greg. Greg really didn't, Hobbs, when we talked about HALT, he didn't really emphasize what I think is one of the key benefits of HALT in digital systems, is changing the signal timing through hot and cold. And that other companies have since Greg's gone, have discovered this, especially with software and firmware testing, that you can actually skew the timings of chips and everything by heating and cooling them. Yep. Plus clock margining, which Greg never really involved himself in.
It's also pretty expensive to get fast chips and slow chips deliberately made on a small scale.
Exactly. So instead of doing that, one of the things you can do is cool sections of your board, especially thermal gradients across the board will have a stimulus of what you're going to have in variation from lot to lot, and millions of components. You're going to have a distribution. We all know that. Everything has a distribution. Nothing is exactly identical as far as one part after the other. But
you're talking about doing physical things to create more variability in the few samples you have. And hopefully that triggers failures or trips and things like that.
Example of fence, we do get some pretty high winds here. I don't know what somebody builds to the strength, what they expect.
100-year wind.
Well, we've got 90-mile-an-hour winds in the Front Range some places, and I'm sure right next to out there in our...
Well, that causes problems in your neck of the woods, especially that big fire that ripped through your neighborhoods out there.
That was a 60-mile-an-hour, 70-mile-an-hour wind blowing, just a firestorm across 500 homes.
Yeah.
And this is a rare combination of events, but that's kind of what happens. Is sometimes, and it's usually, especially in reliability in building or manufacturing, it's not just one thing that happens. It's kind of a coincidence of a couple of things.
It's particularly dry, and you had the high winds, and it was the right scope and direction, and it had an ignition that got out of control.
Yeah, they never know where the ignition came from. We've got mines that are burning underground, coal mines that are still on fire.
Oh, wow.
Still, and they've been doing that for 40 years down there. Wow. And sometimes they've broken through the surface. Even those mines have been closed, you can't ever quench that kind of fire because it's burning in channels.
Basically in solid rock.
Solid rock. it's just going to do that for centuries, or who knows how long. But they suspect that it broke out, and that was the first thing. And then the wind blowing so hard carried it, and then the proximity, because it came into Louisville and the houses were so close together that they just, so those
popped one after another. But the issue is that I mean, if the scenario is that it takes a sequence of unfortunate events, to lack of a better term for it, to happen, there's an infinite number of those if we're looking at a product. But I know from sitting in reviews is that there's usually one or two people that go, have you thought about, or what about this? Or that looks like a stress concentration there. And usually a material or mechanical engineer,
right.
Or, you and I would look at it from our experience and go, you might want to change that spacing there. Or, have you looked at this, or what's the torque on that? And,
right.
Things like that. Or my favorite is looking at one going, do you have problems with that connector falling out? And how'd you know that? Well, you can't see it, and it doesn't have a latch on it.
Right.
It's a blind insert.
Very difficult to insert in the manufacturing process. Right. You have no lock. It's next to another, it doesn't have a strain relief on the cable, things like that.
All kinds of stuff. You just look at it and go, that's the problem, guys. That you might have solved that one. But that comes with experience, right?
Right. And either experience or, I hate to bring this up, but maybe
no, you don't.
Maybe you stress it. Maybe you put it in and do some vibration.
Yeah. No, I knew that was coming.
Electrical margining. Maybe you do something to see how strong it is, or if it can be broke easily.
That provides a rapid way to build experience too.
Right.
So so that the next time before you go to halt, you can put money on saying, I think this is going to fall apart right here. But
then go look at the field and see if you were right or not, or you really overstressed it, and that's never been a problem in the field. You got to challenge yourself, and then you've got to go be willing to accept that may not be a real problem, and or it may not show up in the field, or it hasn't shown up in the field, or there's another reason it was structurally different, or somebody attached it a different way, or something like that.
Well, there's two other sources, I think, rather than, I agree. Put some stress on it, do a halt, and learn as much as you possibly can, and do the confirmation. That all makes perfect sense. Now, there's two other techniques I think are worth mentioning here. One is in a design review, or as you're working with the development team and talking to them, is going, what are the areas that are the trickiest for you? What areas are you worried about? And it might be that there's a particular trade-off in a particular part of a design, or, I don't have enough room to give this enough mechanical support here, so it's probably going to move too much, and I don't see a good engineering solution that's cost-effective. And then that gives me a clue, is that when I go into the lab, let's monitor that. Let's look for that, or let's do the finite element and see what really is happening there, or what let's investigate that. Is the concerns of the developers and design teams is one technique. The other one is go talk to the manufacturing engineers,
exactly,
and the technicians and the folks putting the stuff together, going, where are the tricky parts for you? What, and the same with suppliers. Let's go ask them. So
especially the first prototypes, and if there's any predecessor product that's come from the field, but you got to go talk to the people that do put the hands on, to do assemble it, and see what they've had a challenge with, because that probably identifies something that is going to be a problem in the field if it's a challenge to assemble. I can't get my screwdriver in that.
So we just kind of wish it works. We get some dental floss out and twist it around a couple of times and hope it holds.
Yeah, exactly. We just got some RTV and just
we glue the
thing. Yeah. that old caulking gun is great.
Yeah, I know. But there's you can tap into other people's experiences and people that think through the design problems, people that are thinking through how to assemble it, people that are doing the assembly. And then, like you said, is if you've got a similar product in the field that's using, say, the same power suppliers, using elements of it, what's your field telling you? What's the information you're getting back there?
It may tell you don't need to worry about that part at all. it's shown very good reliability. Don't bother with that section. Go to something else. And usually it's the new section, the new component you're using, or the new processor, or if it's lead to lead free. Those are the things to be concerned about.
Yeah.
The chip itself, like a CPU, those were rarely ever a problem. We didn't even. That's why I never really concerned myself with, not including that, having to cool it down to operate the rest of the board at to its limit because of the thermal trip built in. I never wanted that to engage. But if the CPUs had been a problem, we would have focused on testing those too.
Yep.
But that was Intel and AMD's thing. So anyway, it really is an experience. Let's go back to this fence. The designer might have said, hey, 2 posts between these 12-foot things and with the gate on it, it's going to last 25 years. Yeah. Well, he was right.
He was right. Yeah. And the other thing too is that
I can't put another post in there for 50 years. Whatever.
Well, you could put one every 4 feet, and it'll last 100 years.
Yeah.
But they'll invent a new weevil of some sort that'll attack that particular kind of way. Now, there's another factor to consider though. Is back in the 80s.
Yeah.
Right. And I don't know this for sure, but here's this one thing that might be worth looking at. Is take that old post out, cross-section it, and look at how hard that wood is. What kind of wood, and how is it old growth stuff that's much stiffer.
Right.
Even pine today is engineered that it grows amazingly fast. And you can see it in the ring structure, is that it's structurally not as solid and resilient as the older growth stuff. So
it's true. They have had trade-offs in producing trees faster, that they've genetically modified things to do that. And they don't know that maybe, the strength, well, they should.
Well, they do. No, it's known. I know from
you break a board, you put it in. Yeah, in a press, and you measure at what point it breaks. That's kind of what we do with Hall.
But it's a changing the. I mean, we used to be able to use a solid fir beam to support a structure, right? And it would be a particular size. And then the architects and mechanical engineers designing these things are now using glue lams, which are an engineered structure of glue and wood structure, design with a certain arc in it and everything else, that because they can't get solid beams that have the strength anymore because they're grown too fast, or it's incredibly expensive because they have to fish it out of a levee someplace where the wood's been preserved for 100 years. There's actually, you can get wood like that.
Right.
It's old growth. But
mahogany, I think, is a wood was very extremely rare, but extremely hard.
Yep.
So
not anymore. It's soft as balsa wood nowadays.
At the same time, they're doing better treatments, heat treating or chemicals, maybe to pressure treat wood. I don't know. There's also alternatives, polymer, looks the same as wood.
Well, it doesn't. It's too regular. I've got a deck in my yard. It's this plastic stuff.
Yeah. Okay.
It works. It works. You can walk on it.
You don't fall through. That's right. Whereas wood, it rots, and eventually you could fall through. In fact, we have a wooden deck that we're going to have to replace because the wood has gotten old. And that's part of it. That's something we know about, and that's a thing we can measure.
Hey, we're going to make a reliability engineer out of you after all.
Yeah, too late, Fred.
I understand.
You can't teach this old horse. No, I tried. No, I tried.
You try.
I always looking at the industry and looking through articles Google sends me anything that has reliability in it. Mm-hmm. And so I scan every day and look and see if there's things that, I can comment on. And so I try and keep a little bit fresh because I'm not real busy in the industry, but I do get to see, occasionally new projects from potential customers.
Yeah. No, there's all kinds of stuff going on, and it's exciting. But one of our key roles is narrowing down what does this team need to solve what do we need to work on? What areas do we need to monitor or look for? And HALT is a tool that we use to do that.
HALT is a tool.
But also our experience, but also talking to other people with hands-on experience or where's the trade-offs being made? What's new? There's lots of techniques to get a list and then focus in on the trivial few is the way Chris likes to say it, the trivial few things that will make the most difference.
Right. And it's all dynamic and changing all the time. And you've got to, keep up with it. And I'll be willing to accept new materials and new methods and, adapt.
Yep, definitely. And hopefully your new fence will last the winter. So it'll be all good.
For a while, yeah. I'm
You're
sure
not out there swinging on the end of that gate, are you?
That's it. I knew that was a problem.
You could hear the wood cracking.
200 pounds on the end of a 3-foot, levered. Yeah,
that would be a problem.
Be a problem.
Well,
some use. Yes.
Yeah, no, you can go play with it again next week when the fence is all done. So.
I'm going to go ride it. Yeah.
Okay. All right. Well, thanks, Kirk. And so if you've listening to this, and if you got some other ideas of how to identify those weak points, and we threw out a handful of ideas there, let us know. Head over to accendoreliability.com/go/SOR. In a couple ways you can get in touch with us there. Kirk and I and the other hosts can be contacted through LinkedIn or on contact information on our About pages. So plenty of ways to get in touch. And if you've got some good tips or ideas and identifying weak points, let us know. We'd love to hear from that and be glad to share it with this audience. So with that, Kirk, I think...
All right.
Luckily we didn't run into any weak points in our connection today, so everything's working.
No, it worked today, and we'll continue to
stress it as we go.
No, have a good one, Fred, and thanks everybody for listening, and send in your questions. We love to hear what's going on in the industry and what the challenges are for you in reliability.
Yeah, well said. Thanks, Kirk.
All right, Fred. Talk to you later.
Cheers.
Bye.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.